Hello students, good morning. If you remember in the last period we completed that the period determined the number of shell and the group determined the number of valence electron present in an atom. Now today in this period we start with the new topic, that is a periodic properties. What they are? The properties of the elements which are directly or indirectly related to their electronic configuration, and they shows the regular gradation. Regular gradation means either it is increases in a uniform way or either it is decreases when we move across a period or down the group. That properties are known as periodic properties. There are total 6 important periodic properties. The first one is atomic size. The second is new metallic character. The third one is non-metallic character. Fourth one is ionization potential. Fifth one is electron affinity. And sixth one is electronegativity. I repeat, periodic properties. The properties of elements which are directly or indirectly related to their electronic configuration, and they shows the regular change. Regular change means either it is increases or decreases, which is called as a regular gradation, that we move across a period or down the group. That properties are known as periodic properties. In our syllabus, there are the 6 important properties are included. Let me repeat again them. The first one is atomic size, second is metallic character, third one is non-metallic character, fourth is ionization potential, fifth is electron affinity, and sixth is electronegativity. Now let's start from the first one, that is atomic size, which is also called as atomic radius. How we can define it? It can be defined as that it is the distance between the center of the nucleus of an atom and its outermost shell. It is the distance between from the center of the nucleus up to the last shell. This distance is called as atomic radius. It also can be defined as the half the internuclear distance between the combined atom in a molecule. In a molecule, how the molecule is formed? It is a combination of 2 atoms. This is the nucleus of the first atom. This is the nucleus of the second atom. When the 2 atoms are combining together, they form a molecule. Now from this one nucleus center to the other nucleus center, this distance is called as a internuclear distance. The half of this internuclear distance is called as a atomic radius. So in a molecule, we can define it as the half the internuclear distance between the combining atom in a molecule. The unit in which the atomic size is measured is angstrom. The 1 angstrom unit is equal to 10 raised to minus 10 meter. And the second unit is picometer. 1 pm, that is a picometer, is equal to 10 raised to minus 12 meter. Please remember this relationship can be asked in the form of the fill in the blanks or the name of a unit in which the atomic size measured. Now the factor on which the atomic size depends. The atomic size depends upon the following factor. The first one is the number of shell, second is nuclear charge. Let me consider the first one, number of shell. As the number of shell increases, size of the atom also increases. We remember that as the number of shell increases, the size of the atom increases, because the distance between the outermost shell and the nucleus is increases. As the distance between the nucleus and the last shell increases due to the number of more shell, the atomic size also increases. The second factor on which the atomic size depends, that is a nuclear charge. An increase in nuclear charge decrease the atomic size. Remember it. Increase in the nuclear charge decrease the atomic size. Now first of all we come to know point the what do you mean by the nuclear charge. The nuclear charge, we can say that the positive protons which are present in the nucleus, due to which the nucleus is affect the electron, it attracts the electron towards itself. That attractive force is called as the nuclear charge. So as the number of new proton in the nucleus is increases, that is called as the increase in nuclear charge. Then the size of the atom is decreases, because due to the greater attraction the electrons are attracted towards the nucleus with the greater force, and the size is it decreased. As the nuclear charge increases, the size of the atom decreases, because the electrons are feel the more attractive force, so they get nearby the nucleus, thus the sizes decreases. Now we will come to the next point, that is trends in the atomic size. Trends, it means its variations of the atomic size in the periodic table, how it changes down the group and how it changes across the period. That is called as the trends of the atomic size in that periodic table. Let me consider the first, down the group. Down the group, it means in a particular group when one person move from top to bottom, that is called as a down the group. Atomic size increases down the group because due to the successive addition of the shell. As one move from one period to the next period in a group. Now what it mean? Let I repeat again. Atomic size is increases down the group. In a particular group, the atomic size is increases because the number of shell is also increases. Addition of successive shells goes on, increases. How? That can be understood by the example. Let me consider the group 1, that is a first A group. The elements of the first A group are hydrogen, lithium, sodium, potassium, rubidium and cesium. The number of a shell in the hydrogen, there is a 1 shell. In the lithium, there are the 2 shells. Sodium, 3 shells. Potassium, 4 shells. Fifth, rubidium, 5 shells. And the cesium, 6 shell. Also, we know that when we move in a group, when we move from one element to the other element, the next element will belongs to the next period. As the number of period increases, the number of shell also increases. Hydrogen in the first period, therefore it is having the 1 shell. Lithium in the second period, therefore it has the 2 shells. Now from the lithium, when we move to the sodium, sodium is belongs to the third period, so it have the 3 shells. From the sodium, when we move to the potassium, potassium to it belongs to the fourth period, so it have a 4th shell. From the potassium, rubidium belongs to the 5th period, having the 5 shell. And the cesium lastly belongs to the 6th period, so it have the 6th shell. As the number of a shell increases from top to bottom, atomic size also increases. So we have to be remember it, the atomic size increases down the group when one move from top to bottom. Now across the period, how it changes, how it's vary, either it is increases or decreases across the period. In a period, atomic size decreases from left to right. Remember it, from in a period, atomic size decreases from left to right because nuclear charge, that is the atomic number, increases. Number of shell remain the same because of the same period. Therefore, effective nuclear charge goes on increases from left to right, and thus outermost shell become more closer to the nucleus. Thus, we can say that in a period, atomic size decreases when one move from left to right. How we can understand this? This we can understand by an example. Let me take the example of the second period. The elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Atomic numbers are lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9. Their electronic configuration: lithium 2 1, beryllium 2 2, boron 2 3, carbon 2 4, nitrogen 2 5, oxygen 2 6, fluorine 2 7. From the electronic configuration, what we understood? We understood that the number of shell remain the same, as all the elements are belongs to the same period. Thus, the effective nuclear charge is increases. Effective nuclear charge is increases. Thus, atomic size decreases. So, there is a contraction in the atomic size takes place. We remember again, I repeat it, in a period when one move from left to right, effective nuclear charge is increases due to the increase in atomic number. Number of shell remain the same as all the elements belongs to the same period. Thus, atomic size decreases when one move from left to right. Now, we have to remember the special notes related with the atomic size. The first one is that the size of the inert gases are bigger as compared with their respective halogen. The size of the atoms of inert gases are bigger because the outermost shell of the inert gases are completely filled. Already we knowing it that the inert gases have their stable electronic configuration. They have the 8 electron in their last shell, and due to that they have the maximum number of electron, and they should experience the more electronic repulsion. Due to this electronic repulsion which takes place in the last shell, the size of the atom of an inert gases is bigger than their halogen and respective halogen in their period. So this is about the first note. I repeat again, the size of the inert gases are bigger in their respective period than the halogen because the outermost shell of the inert gases is completely filled due to their stable electronic configuration, due to their octet electronic configuration, as they have the 8 electron in them. They have maximum number of electron in their last shell. Due to that, there is a strong electronic repulsion. Due to this repulsion, their size little bit get expand as compared with the halogen in their respective period. Now the second note is related with that the cation is always smaller than the parent atom from which it is formed. I repeat, cation is always smaller than the parent atom from which it is formed. This we can understand by taking example. Let's see it. Sodium, atomic number 11, its electronic configuration is 281. From this electronic configuration, we can understand that in a sodium atom there are the 3 shells. By the loss of 1 electron, it formed the sodium cation. It have the electronic configuration now 2 8. To attain this stable electronic configuration, the sodium is loses 1 electron, and thus now its electronic configuration become 2 8. Due to the loss of 1 electron, now the last shell of the sodium atom is also disappear. Now it have the 2 shells. As the number of a shell in a cation from the parent atom is less, therefore the cation is smaller in size. I repeat, cation is always smaller in size as compared with their parent atom from which it is formed, because in the cation, due to the loss of electron, the number of shell decreases. This is the first point. Also the second point, that in the atom the number of electrons and number of protons are always equal, but in a cation the protons are greater than the electron, so the effective nuclear charge is also more. So these two factors affect the atomic size of the cation. It's become the smaller than its parent atom. Now the next is that anion is always larger than the parent atom. It have the greater size than the parent atom from which it is formed. Why? Because the anion is always formed by the gain of electron. To attain the stable electronic configuration, atoms takes the electron, form the negatively anion. Now let's take the example of chlorine. It have the atomic number 17. Its electronic configuration is 287. By the gain of one electron, the chlorine form the anion which have the electronic configuration 288. That is a stable octet, stable electronic configuration it achieved. So the number of electrons are more as compared with the number of proton in an atom. The number of electrons are more, and the effective nuclear charge is become now less, and due to that the size of the anion is expands. Thus we can say that anion is always greater than the parent atom. Now the next point is that size of isoelectronic ions. Let we come to know the meaning of the isoelectronic ions. Iso means same. Electronic word is taken from the electronic configuration. So the ions which have same electronic configuration, that ions are known as isoelectronic ions. I repeat, isoelectronic ions means the ions which have the same electronic configuration. In this case, as the nuclear charge increases or greater the nuclear charge, smaller the size of the ion. The ion have the smaller size when it have the higher nuclear charge. Let me take the example of the ions like magnesium cation, sodium cation, fluoride anion, oxide anion. The number of electron in each ions are 10, 10, 10. After this donating electron by the magnesium sodium cation, and after receiving the electron in a fluoride and oxide anion, all these ions have the same electronic configuration, that is a 2,8. That's why the same have the same number of electron. Therefore they are known as isoelectronic ions. Now in this case the magnesium have atomic number 12. It have the 12 proton. Sodium atomic number 11, it have the 11 protons. Fluorine atomic number 9 means 9 protons. Oxygen having the atomic number 8 means in the oxide anion there are the 8 protons. So as the number of protons are more, it means they have the greater nuclear charge, then the size of the anions will be smaller. Thus magnesium cation will have the smaller size than the sodium cation. Sodium cation have the further smaller size than the fluoride anion. Then the fluoride anion will have the smaller size than the, I repeat again, magnesium cation will have the smaller size than the sodium cation. It means sodium cation is the greater in size, and the fluoride anion is greater in size than the sodium cation, and the oxide anion will have the further greater size than the fluoride anion. As the nuclear charge there decreases, the atomic size increases. I repeat, nuclear charge increases, size of isoelectronic ion decreases. Vice versa, it means nuclear charge decreases, size of atomic isoelectronic ions increases. So we repeat today what are the points we had just completed. The first we had completed the definition of atomic size. Atomic size is defined as the distance between the center of the nucleus up to the last shell is called as a atomic size. Its unit is Armstrong unit. We already knowing it. 1 Armstrong unit is equal to 10 raised to minus 10 meter. It also measured in the picometer. 1 picometer is equal to 10 raised to minus 12 meter. Then the factor affecting the nuclear size. The first factor is number of shell. The second factor is nuclear charge. We remember that number of shell increases, atomic size also increases. Then nuclear charge increases, atomic size decreases. These are the two factors on which the atomic size depends. Then we come to the next point, that is the of the trends of the atomic size in the periodic table. The first is down the group. As we move from top to bottom, atomic size increases. Why? Because the number of shell increases and nuclear charge decreases. So this is the first variation of atomic size in a group. It is always increases in a group. Then in the period, across the period, it means when we move from left to right, atomic size decreases. Why? Because the number of shell is remain the same and nuclear charge increases. Due to that, the atomic size decreases. The contraction in the atomic size takes place. Then we completed the spatial note. The first note is that inert gases have bigger size. Why? Because the inert gases have their complete electronic configuration. Due to the 8 electron or the maximum number of electron in their last shell, the electronic configuration, the electronic repulsion takes place. Then the second we had completed that cation always smaller than parent atom, because in a cation, first point, number of shell is less and the effective nuclear charge is more. Therefore, the cation is always smaller than the parent atom. The third point we had completed that anion always greater than the parent atom, because an ion is formed by the gain of electron. So in an anion, more number of electrons are there as compared with the parent atom. So the electronic repulsion takes place. Effective nuclear charge decreases due to that anion size is greater than the parent atom. And the fourth point we had completed, that is about the isoelectronic ions. In the isoelectronic ions, the nuclear greater the nuclear charge, smaller the size. So up to this point we had completed. We will continue in the next period. Thank you.